We have talked about extratropical transition of tropical cyclones. We will add a little bit more detail here. We saw that many of the tropical cyclones end up making landfall or running into very high shear cold waters and fall apart and so on. But a fair number of them, sometimes up to 50%, depending on which region of the world and which month and so on. Many survive into the extratropics and then make landfall. You can see this one started here, Typhoon Tokage, which went from October 13th here to October 24th over there in Alaska. They get re-energized sometimes. They have impacts on the extratropics. They can drive waves and have remote influences of generating extratropical storms away from the region of the extratropical transition of a tropical cyclone and so on. So many conditions are required to make them transition. Many of the ones that actually make landfall in over the US tend to curve back out onto the ocean and survive into the extratropics and go far. So I think some 48% or so can survive. The likelihood of ET, extratropical transition, for an individual storm depends on the structure and intensity of the tropical cyclone itself. So it depends on how long it can hold itself together. Its thermodynamic environment, so the convective forcing which is required for it to survive and evolve. The structure of the mid-latitude trough, especially the spatial extent and the strength of its associated vertical wind shear. So wind shear is still a key player in chopping off the energy from the vortex and making it lose its identity and dissipate. And so the mid-latitude trough interacting with the tropical cyclone can make it transition into ET or inhibit it, and the relative location of the tropical cyclone in the trough. Okay, keeping that in mind, if we want to look at the climatology of extratropical transition around the world, we are here looking at the distribution of the seasonal cycle of North Atlantic tropical cyclones. September is the peak for tropical cyclones and hurricanes together, and of course a fraction of them make it into hurricanes. And you kind of know that the official season starts on June 1, ends on November 30th, but you have obviously had tropical cyclones forming in other months as well. It's just a matter of the highest probability and numbers, right? If we look at monthly climatologies of North Atlantic extratropical transition events between 1950 to 2002, you have a few in May, June, July, August, and then September is a peak here, and October also transitions a lot of tropical cyclones into extratropical cyclones, and the total number drops here, but you can see the red dots here. So monthly climatologies of North Atlantic ET events over this period. Red dots show the transition point as defined by the National Hurricane Center. You can see the red dots here in each of the months. Not very easy to see, but please stare at it and make sure you know what is being talked about. The latitude range of ET in each month is shown in the box and whisker plot here. Solid black circles denote the mean transition location for each month, and you can see that in May the transition latitude is lower, and June almost the same. It goes northward in July and climatologically drops back towards lower latitudes through August to November. Okay, so you can kind of see that here. So you have lower latitudes and then becoming higher latitudes and then transitioning back to lower latitudes, at least in the mean and the standard deviation around it. Okay, so these are all things that matter, and the mean return period for passage of an extratropical transition within 300 kilometers of the regions shown here for 1899 to 1996. So you can see that this region here sees extratropical return period of 2 years, and there are numbers that then go up to 50 years, 40 years, and the lower ends and the farther north ends here have much longer transition periods in years, whereas the bullseye for repeated extratropical transition is happening in this region to the northern US and into Canadian waters. Okay, this is another way to look at it. This is the annual cycle of regions supporting tropical and baroclinic storm development. So we are looking here in blue colors mean monthly ED baroclinic growth rates of greater than 0.25 per day. ED baroclinic growth rate is basically a measure of the baroclinic instability, which you can think of simply as the vertical shear, where once you pass a critical gradient, you can tip over and create eddy kinetic energy, which is where the energy conversion goes from, let's say, available potential energy into eddy kinetic energy, which can go into a storm. And of course there are regions with monthly mean SSTs greater than 28 degrees centigrade, which are critical for tropical cyclone disturbances to grow and evolve into tropical cyclones, right? We have talked about that before in terms of cyclogenesis and so on. So this is for the northern hemisphere going from January, February to December, and you can see the changes in the sea surface temperature regions that we talked about in terms of the north-south movement of the SSTs with the sun, very clearly seen in the Western Pacific warm pool as well as in the Indian Ocean, and not so clear in the tropical Atlantic, but still it's visible. And the regions here with the dark and light shades correspond to 0.25 per day and 0.5 per day ED growth rates, which correspond to where there is potential for extratropical storms to form. Okay, these diagnostics are calculated from 2.5 degree by 2.5 degree fields for over 1982 to 2001 from the NCEP NCAR monthly mean reanalysis. If you don't know what that means, don't worry so much. NCEP is the National Center for Environmental Prediction. NCAR is the National Center for I think it's National Centers for Environmental Prediction and National Center for Atmospheric Research in Boulder. NCEP is mostly in DC area, and reanalysis is a merging of data and models to reconstruct the past climate record. So extreme values here may be underestimated. Okay, so this gives us a sense of the regions where we expect extratropical transitions and how they are related to the season of the tropical cyclones themselves, and the distribution over the year of where the transition happens and what percentages of them manage to happen. I think the main point is also to remember that the maximum number of cyclones may be born in September, but maximum number of extratropical transitions percentage-wise can happen in October. And the Northwest Pacific has a large number of typhoons and cyclones. So there are obviously large number of extratropical cyclones there, which typically tend to hit Japan, for example. Okay, so this is the basic introduction to